Hello everyone, welcome. We have studied about solid angle in the previous video. Okay, today I have hinted you that in this video we'll be studying about Gauss theorem. Okay, this is a very important theorem uh, in terms of Gauss theorem. Okay, in terms of in such a way that this theorem makes our task easy in finding electric fields. Okay, due to different charge distribution. Okay, and this also has some other uses in flux as well. Okay, so the statement what Gauss theorem says. Okay, it says that the total electric flux, okay, total, I'm writing it as well, just a second. Total electric flux linked with the surfaces one upon epsilon naught times the net charge enclosed by that surface. Okay, closed surface. Okay, or you can also say it as a Gaussian surface. Okay, so this is a basic statement of Gauss theorem. Okay, that the total flux linked with a surface is 1 by epsilon naught times the net charge enclosed by closed surface or Gaussian surface. Okay, this is a basic statement. I'm writing it so that it will be more clear to you. Okay, so if I write this statement in mathematical terms, what will be it? It will be the total flux linked, let's say it is phi, is equals to the total flux through a surface, let's say we are saying it as S, okay, through a surface is 1 by epsilon naught times the net charge enclosed by the closed surface. Let's say the net charge enclosed is Q net. So this will be the what? This will be your mathematical expression, okay, of Gauss law, okay. And we know that electric flux linked with the surface is what? It is E dot dA, okay. And if it is a closed surface, this circle will come on integration. Okay, I have told you this notation in previous videos. Okay, and yes, so this is a whole mathematical expression for the Gauss law. Okay, now you need to write some important points regarding Gauss law. Okay, suppose this is a closed surface. Okay, let's say a charge q1 minus q2 q3 plus q4, these are positive charges. Okay, if someone says and here minus q5 and plus q4, okay, if someone says that calculate the net electric flux or the flux through this surface, okay, this is what Gaussian surface. Okay, you need to calculate the flux through it. Okay, then I have told you this q net is actually the q enclosed, that is the net charge enclosed within the surface. Okay, so flux will be what? It will be q net upon epsilon naught, and net is what? This is actually q enclosed, okay, within the surface. Okay, and what is the net charge that is enclosed within the surface? That is what? It is q1 minus q2 plus q3 plus q4. This will be the net charge divided by epsilon naught. this will give what? This will give electric flux. Okay. Here we don't need to think about the outer charges. Okay, these charges. Okay, this will be the flux linked through this Gaussian surface. Okay. So what point you got from here? That is the important point that you have got from this, that flux through Gaussian surface depends only on the charge that is present inside the surface. Okay, that means the flux will depend only on the charges which are present inside the surface. Okay, and electric field intensity will and one more thing, that electric field intensity at the Gaussian surface is due to the all charges present inside and outside the Gaussian surface. That means if someone asks that what will the effect of vector E, that is electric field intensity, okay, then uh, this will be affected by both the charges inside and outside the charge. Okay, now if you note the second point. Okay, what was the first point? That flux associated with the surface depends only on the net charge included within the surface. Okay, the second point, that flux through a Gaussian surface is independent of its shape and position of the charge inside the Gaussian surface. Okay, flux, this phi, is what? It is independent of size, okay, shape, size, or you'd say shape of Gaussian surface. Okay, and also position of the charges. Okay, position of charges inside the Gaussian surface. Okay, let's say this is a Gaussian surface and here charge q is kept. Okay, let's say this is q, this is minus 2q, this is 3q, and this is plus q. Okay, again let's say this is a Gaussian surface. Okay, here plus q charge is here, minus 2q charge is there. Okay, here 4q charge is there. Okay, so if someone says that flying flux through this, that will be what? 3 plus 1 plus 1, 3 to 5 minus 2, and 3q by epsilon naught, and flux through this will be 4 plus 1 5, 5 minus 2 3, 3q by epsilon naught. So what you see, you have seen that flux is independent of the position of charges and the shape of the surface. Okay, the next point you need to note, that for a Gaussian surface, if flux associated is 0, okay, what I'm trying to say, if phi is 0, okay, so this necessarily does not implies that E is 0. Okay, means if phi is 0, then ये आपका जरूरी नहीं होगा कि E भी क्या हो 0. Okay, but if E is 0, okay, this implies phi must be 0. Okay, means if electric field is 0, then flux will automatically be 0. But if flux is 0, then electric field may or may not be 0. Okay. So this was all about the basic introduction about Gauss law. Okay. Now I will give you one question. Let's say this is a cube. Okay. Here a point charge capital Q is placed at the center. Okay. Then you need to find flux through whole cube, and second through each face of the cube. Okay, just think for 10 seconds. Okay, I think you have done this, the first part. Okay, so flux will be what? It will be q over upon epsilon naught, and through each phase. Okay. If how many phases that does cube have? It has what? 6 phases. So flux through each phase will be, that will be q upon 6 epsilon naught. Okay. So this was the basic question about the flux. Okay. Now in the next video we'll be studying about the application of Gauss theorem. Okay. Thank you. And application of Gauss theorem means we have find electric field by our generalized method. Okay, here we'll be using Gauss law to find the electric fields. Okay, due to different charge distributions. Thank you.